As a side note, how many lines through? How many lines at most can pass through? How many lines can you draw that pass through 2 of 3 distinct points? Really? You can draw an infinite number of lines through these? How many do you say? What's the most number of lines you could draw through 2 of them? 3. You could have 1 line, 2 lines, 3 lines. What's the minimum number of lines that could go through 3 points?
1.
1, because all 3 points could be on in a row. They could be on 1 line, right? So you could have 3. So this gets more fun if you add in a third, but we're not talking about that right now. We're talking about 1. So this is related to, and we're going to use this inside this question right here. What is an x-intercept?
The one where the graph intercepts
The graph intersects the... Yeah. Yeah. The x-axis. That's correct. Can someone simplify that? Where is that? The point where...
It crosses the horizontal.
X is 0.
Not where x is 0. It's the point where y is 0. Right there. The x-intercept is when y is 0. And then likewise, what's the y-intercept? The point where the graph, yep, intersects the y-axis, and in this case, x is 0. What word did I underline in both of those? The point. If I asked you for an x-intercept and a y-intercept and you give me a single number, is that correct? No. What is a point? It has 2 coordinates, an x-coordinate and a... Some of you got a little bit of points off on the quiz because what did you not put around your point? Parentheses. A number, comma, a number isn't a point. Parentheses with numbers inside them and a comma, that is a point. So make sure that happens. So let's say I asked you about these 3 lines right here. Let's say I asked you to identify some intercepts on these 3 lines. On number 14, can someone tell me the y-intercept? Go. What's the y-intercept?
3.
Nope. What's the y-intercept? Yep.
2.
Nope. Can someone tell me the y-intercept? Jonas?
On number 14?
Yes.
About 0, 3.
Thank you. That is the y-intercept. Just said that 30 seconds ago. My little goldfish. My little goldfish. Oh, the castle. It's a surprise. A castle. A castle. A castle. What's the x-intercept?
Okay.
Do you understand what I'm referring to?
Yeah, goldfish forget what they do.
Yeah, I know, like 10, 2, 7. Castle. Yeah?
0,
Nope.
2, 0.
Ah, look at this. We're 50-50 so far. Okay, let's warm up a little bit. Number 15. Who wants to tell me both intercepts? Xavier, what's the y-intercept?
Y-intercept.
Yep.
0.
Yep.
4.
Yeah, woohoo! What's the x-intercept?
The x-intercept is -2, 0.
Yeah, good job. And on this one right here, can someone tell me what the y-intercept is? Who wants to do this one? Who wants to do this one for me? Someone new. Go.
0, -1.
0, -1. Good. And what's the x-intercept?
-4, 0.
Yeah, exactly. Identifying intercepts, they're points. They're points. Don't be lazy. Don't be wrong. Get full credit on these things, okay? So what did he do? He labeled and hopefully used a few more words to label your variables. Just take a little bit more. You created an equation. What could you do at this point? Some of you did this. What did you do to that equation? Yeah, 2y plus x is equal to 15. Is it a little easier to work with that? Yeah, a little easier to work with. You then graphed it. You looked at the first quadrant. I liked how you made it the scale a little pretty good there. And then you can answer this question. 6 and 3, it just has to be twice. So what happens if the child price was $1? That's this point right here. What point is that on there? 1 comma. If the child price was 1, what would the price be for adults? What would it be? 6.5. Because twice the adult price plus the child price has to be 15. We simplified it to 15. So you have all these different prices. It could be $1 and 6.5. You can slide this point down and get different prices every single time. Realistically, though, are there an infinite number of different prices? Why aren't there an infinite number of different ones? What's the reality check for money? You can't have what?
Only has 2 decimal points.
2 decimal points in reality, right? So I could ask you a fun question, like how many different prices could you charge if you can only charge in cents? A lot, but not an infinite. Closer to an answer?
Yeah. Can we just try 48?
So this could be 2, good. And this is unfortunately not an integer yet, so one of them is an integer. So what k value do you want to try?
48.
K is equal to 48. Are there, there's more than one answer? Yeah. So 48. So it's 48. So I could be specific, but we're asking a general question right now. What if you just so if x is 0, what's y going to be? 6. If y is 0, what's x going to be? 8. Are these both integers? Yes. So what's another value that could work? K equals 24. It does work indeed. You have 6x plus 8y equals 24. It'd be 0, 3, and 4, 0. How many different possible answers result in integer x and y intercepts? How many? There's what? There's an infinite number of them. How would you describe them? 24 works. 48 works. K needs to be a multiple of 6 and 8. What's the smallest common multiple? What? I'm not whatting you, I'm whatting him. Of 6 and 8. What's the smallest common multiple? 24?
Yeah.
12? We tried 12, it didn't work. It's 24. So it's 24. So the smallest multiple is going to be 24. So what would you say? K is equal to 24 times n, where n is equal to any integer. Where n is equal to any integer. So for example, 24, 48. What's the next one?
Yep. Gosh.
What's the next one? 72. Exactly.